Let's find the inverse of this 3 by 3 matrix given here. We're using the method of cofactors, so we're going to need a lot of determinants. First, the determinant of A. We're going to use Laplace expansion because you have a nice 1, 0 here, but instead let's use the rule of Sarus. So I write out the first two columns for convenience, and now we take the sum of the products of the diagonals going from top left to bottom right, and then subtract the products of the diagonals going from bottom left to top right, which is 8 and then 0 and plus 6. That adds up to 4. Now we have a 3 by 3 matrix, which means 9 cofactors. Now instead of listing them, sort of evaluating them one by one, C11, C12 and so on, let me just create one big inverse matrix from the definition, and I'm going to write the cofactors inside this huge matrix. So first you have the 1 over determinant, and now the big matrix 3 by 3, 2 by 2 cofactors. Now first you have -1 to the power, which is the sum of indices, which is a power of 2, so you're going to have a plus. Okay, I'm not going to write -1 to the power, just write pluses and minuses. Removing the first row, first column leaves us with this submatrix. Now in the second entry you have -1, 2 entry, so the sum in the power is 3, so you have a -1. Now remove first row, second column, and you're left with this submatrix. And now again you're going to have a plus, because it's a first row, third column, -1 plus 3. Remove the first row, third column from the matrix A, and you get this submatrix. This matrix will be transposed, so let me put a T here. Now we're going to second row, first column, which will be the cofactor with index 2, 1. That's a sum 3 minus 1 cubed, that's -1. Remove second row, first column, and you get this submatrix. And now we're going to have a second row, second column, so it's a plus, right? 2 plus 2 is 4. Remove second row, second column, and this is what you get. So now the next sign will be a minus. As you can see, it just creates this checkerboard of pluses and minuses. Here, second row, third column goes away, so this is what we have left. And finally, the last row, since we have a plus going down the first column, you have a plus, minus, so now you're going to have a plus. Third row, first column goes away. What you're left with is this submatrix. Now the checkerboard tells me negative. Third row, second column goes away. And finally plus, third row, third column removed, leaves us with this submatrix. And now all that remains is evaluating all these little determinants, 2 by 2 determinants, and filling in the numbers. So here we go. 4 minus 3, that's a 1. Then we have 0 plus 2 with a negative in front. 0 minus 8, so -8. Copy the transpose. Now we have -5 plus 3 with a minus in front. This is 0. Here I have -4. Keep going. 5 minus 4 is 1. Then -2 with a -2 and 8. And the last bit that remains is just completing the arithmetic, which is dividing everything by 4. So we have a quarter, -half, there you go, and that's that, and just divide them one by one. Right? Obviously I'm writing in the columns as rows because I'm transposing in one step. And that's your inverse matrix.